This one is unique, being that it's really like a greenfield project because it is outside of the boundary limits of the mill. But it's a greenfield project at an existing paper mill. So this is a unique setup because the paper mill needs the steam and the utility needs the power. But the relationship between the two is a very unique relationship, and actually it's a great idea.
The interesting thing about this is that there are two sources of revenue. First, the utility extracts the electric power for their use, for distribution to the local system. And second, they're selling steam to the mill, which is another revenue stream that helps offset the cost of the CHP.
The gas comes in, fires the turbine creates power, which goes back to the substation, which then gets pushed back to the grid. And then throughout the combustion process, the turbine creates heat. Heat goes through the boiler, heats up the drum, creates steam, which the steam goes back and supplies steam to the paper mill.
This project is about 76% efficient, which is one of the higher ones we've done. Some has to do with the fact that we are also providing heat for their process water to the mill. Typically, we average 67 to 71, 72%. This is 76% efficient. A lot has to do with that we are extracting the thermal and the electric in a very optimal manner. This gas turbine fits the profile of the Rainier mill. In addition to that, we've added 2 or 3% to heating up their process water, which is also a waste heat byproduct that we recover the wasted heat that's going up in the stack and heating up their process water so they don't have to add more fuel to their boilers to do the same heating effect. And so it is one of the more efficient projects that we've done, which bodes well for the industry. Teamwork was very essential. We did this project on a fast track. The way we define fast track is that we're just a step ahead of the contractor. When we start the design, none of the major equipment had been committed to. So when you commit to them, they have 6-8 weeks to make drawings so that we know what it's going to look like, but you can't delay the project by 6-8 weeks. So we started to assume things and started the design and make the adjustments as we would go along. CHP is a win-win, especially when owned by the utility for all. They are getting a cycle efficiency of 76%. Now if you compare it to the central power plants, a coal-fired plant that the utilities have been building, the most efficient in today's technology has an efficiency of 40%. The next stage is a combined heat and power, which takes steam and has steam turbines. That is one of the more deployed technology today. That reaches 50%. We're at 76%. So who wins? The customer rate base wins. Rainier wins. They have deferred some capital cost. FPU gets a source of power that is 76% efficient. They retain their customer. They're generating some revenue from the steam side. Everybody comes out ahead in this project.
We've got a low-cost source of steam coming into our facility that as we have operational changes, whether by design or not by design, by unfortunate circumstance, allows us then to take on steam, take on additional power as we may need to, and stabilize our operations. So it should, in effect, help us produce more product year-round for the customers who are looking for it in a very reliable way from us. So it really helps, I think, stabilize our operations and reduce our cost of our product.
And so this project is going to help make our plant more successful, make the island more successful, and again ensure that more generations of employees can raise their families here in our community and call Fernandina Beach home.